Thank you so much for coming to my talk. I really appreciate this last session. Today, I'm going to present a paper on Multiview finding blind spots in access denial issue diagnosis, and I'm going to share my understanding on why access denial issues are hard to fix. Nowadays, our information are mostly stored in online services, and the services protect our data in access control policies. These policies are not simple. Each components have their own access control configurations, and then a request might be going through every components, and then every components have their own rules. Managing the policy is like managing a huge palace with many doors. And this policy changes a lot. People come and go, and services evolve constantly. As a result, access denial issues happen very commonly. And this is because system administrators might sometimes not understand the root cause of the access denial issues. Many times, access denial issues are hard to fix. First of all, sometimes we don't understand the root cause, so we fix something that we thought might be right, and then we realize another issue pop up. And second of all, even if we know the root cause, there are many ways of fixing it. This is because access control is highly contextual. Sometimes one solution might be I give you a new set of keys, or I give you a new role, or I lose the protection of the resource because the resource should be more public. And there's no way to automatically assign the solutions to different situations with different resources. System administrators need to decide based on the situation they are in. And most importantly, we don't really understand the impact on the system with each control policies. The policies are not usually granular into the level of each object. Sometimes one policy changes might touch many objects and might touch many users. Here's a real-life permission issues that might help us to understand why this is difficult. For example, a user was trying to access the online service, and then it was denied. And here's a service log that system administrators might see. They see that Apache was not able to access the file systems. However, when the system administrator trying to access the resource, it has no problem, and then it was confusing. Until further resource, they realized that the PID is an Apache user that was automatically generated, which is different from the typical Linux user that a system administrator might use. As a result, this Apache user lacks the correct permissions. And after pulling their hair and trying to understand the root cause, there are multiple ways we can resolve this. First of all, we can change the owner of this object to Apache, and now Apache will access this, but then the original owner might lose access. Or we might want to add this user to the group www data. However, this means that Apache not only can access this file, but also other resources that this group have access to. And lastly, we can give public read access so that Apache can read this process without having new rules or become the owner of the file. But all those solutions require a very finite understanding of the problems. Most of the times, we're just encouraged to 777 the issues and drop all the protections. Each of them all can allow the access, but then they have different security impacts. And then the security impacts might not be found until later a vulnerability happens. Permission overgrant is not system administrator's fault. It is a hard problem because it needs to both fulfill availability and security requirements. And most of the time, it is very hard because it goes through multiple components, and each components have their own rules and policies. Sometimes we might miss to update a component, or sometimes we might update it incorrectly. Under a lot of time pressure, and it is impossible to ask a system administrators not only managing their service, also understand the access control policy of each service they use. They might be encouraged to overgrant the permissions. And many times in access denial issues, the difference between solutions and the risk only varies in the doses. And we see a lot of public forums of system administrators spend hours and hours trying to understand some issues, and they could have spent elsewhere. And we're thinking, is there something we can do to make this process more automated to reduce their chances of making security mistakes? And here we want to propose a framework that can mutate the access control policy following a security order, trying to find different ways to solve the issues. First, we want to identify the root cause policy by mutate the access control policies. And then we want to find the different directions based on the type of the directions. And lastly, I want to analyze the impact of the configuration changes on all resources, not just the denied one, but also the one that might be related to it. To go into further details, first of all, we do toggle analysis, which is a black box approach to root cause the access deny issues. First of all, we want to identify the access deny related policies. We started from the log messages, and then we're trying to collect all the log registration policies that might touch the same resource or the resource with same prefixes. This is based on our intuition that if an object is denied, the governing policies are related to the object with the same prefixes. And this would apply to file system, server configurations, and databases. And second of all, we want to mutate the policy to find the root cause. Under one object, there might be multiple policies. Without going through white box and understand the code logics, we're trying to mutate each rule and see which rule will cause the deny. And this is under the intuition that we assume each access control policy works independently from others. And by annotating these two intuitions into our automatic frameworks, we're able to do toggle analysis on various server applications. Now we have a set of policies we understand that cause the deny. We want to know how we can relax the permissions to solve the issues. The next part, direction generation. First of all, we want to mutate and test different directions. Mutate and test different directions. We mutate the directions based on types of the directions. Some of the directions trying to grant user access to additional resource. Some of them trying to modify users' existing permissions. And some are trying to assign a new role to the users. There's no way to reduce them into a single dimensions because this is highly contextual. Only system administrator who understand the situation and then the environment can decide which one is the best for the situation. However, what we can do is that for each directions, we want to reduce the unnecessary permissions with the security order. We have a default security order trying to understand all the permissions in a system and then trying to rank them based on the permission it grants. For example, in the file system, if we give all read and write and execute, that has all the permission, but sometimes we might not need all of them. So we have a partial security order guide us trying to remove the unnecessary permissions. And now we will have a set of directions that could resolve the issues, and then with most permission, with only the necessary permission included. But we want to be able to compare them, understand the impact. We introduce change impact analysis. We're trying to synthesize requests based on the system resources, and we want to replay the requests on two different configurations to measure the impact. A report would look like we'll synthesize the request one with the user and action and resource with before and after, and showing now how this policy has impacted the global state of configuration, not just the denied resource. This black box approach require adaptation efforts. From the developers, we want to understand how to parse the configurations because each systems might have different logic of the parse. Second of all, we need to understand how to mutate the access control rules. So they might need to implement certain mutate functions saying what is a way to grant or revoke permissions. And this is a one-time effort since we realize configurations rules don't change often. However, it could be a considerable effort. And then from the system administrators, we ask them to prepare a testing environment for replaying the requests and inspect the final directions and then the diagnose reports. The evaluation shows, first, we're trying to understand if our tool can resolve real-world access denial issues. First, we collect from public forums to understand what are the access denial issues system administrators are posting online. And then we adopt large application service trying to reproduce some of those issues. We successfully reproduced 112 issues, and we're able to diagnose 89 of them. There are cases we cannot diagnose because they might involve unknown components, such as third-party authentications or USENIX, which we did not annotate. And sometimes those issues might be syntax issues caused by configuration updates, and then we cannot mutate the configuration if the rule has changed. And the second evaluation is we want to learn whether this tool is useful for actual system administrators. We did a user study of 20 users, 11 work professionals, and 9 students. And for each of them, they were asked to resolve 5 access denial problems randomly ordered. As a result, first of all, we want to study the percentage of users who made security mistakes. And then it shows that with our tool, you can reduce the security mistakes. And second of all, we want to understand if this can reduce the average completion times. And then we see that this can reduce the diagnosis time to 1 to 4 times. Our tool is a beginning of understanding how we can build an automatic process to resolve access denial issues, and there presents many limitations. One is that it requires a large one-time effort, manual effort to adopt the system. Second, it should not be made to it should not be used to make final decisions because access control is highly contextual, and the system administrator should make the right decisions. Third of all, Multiview's black box workflow might not apply to all the configuration mechanisms. Our evaluation has shown there are issues we cannot diagnose. Also, the correctness of the Multiview would rely on developers' input. Change impact analysis might be expensive for large organizations, and sometimes it might not be faithfully reproduce certain requests that are non-dependentistic if they are dependent by time or other rate limits. In summary, we're first trying to understand why resolving access denial issues is hard. It's hard to understand the root cause. There are multiple ways of fixing it, and each ways have different impacts. We want to propose an automatic workflow, Multiview, to understand if we can minimize the effort and then help a system administrator to reduce the chance of permission overgrant. We evaluate by doing real-world access denied issues and user studies. And then for more details, please come to our paper. Thank you.